One of the universe's biggest mysteries is dark matter. What is it really? How does it work? Does it even exist? Okay, let's start from the beginning. When we think of the universe, it's such a vast space, like really big. So big that you cannot even picture it. However, astrophysicists observed something crazy. By observing how galaxies move, they found that the universe was expanding, like really fast. This is crazy, and there are more. Stars in spiral galaxies orbit too fast at large radius to be bound by visible matter alone. What does this mean? This confounding idea was what started the basis of what we call dark matter. Dark matter can be understood as matter that does not emit, absorb, or reflect electromagnetic radiation, but does exert gravity. As of right now, the crazy thing is, we only know how dark energy works, not what it really is. Kind of like secret agents. We know what they do, but their identities are hidden from us. Dark matter is real though. We can observe its gravitational effect on galaxies. We have hypotheses for these as of right now and for what they may be. These are not guesses, but ideas grounded in known physics and tested through experiments. One major candidate is the WIMPs, or weakly interacting massive particles. These particles would have mass, interact very weakly with normal matter, and only really make themselves known through gravity. What makes WIMPs compelling is that they naturally appear in the extension of the standard model of particle physics. For a long time, they were the leading candidate. However, despite decades of experiments, deep underground and in particle accelerators, we still haven't detected one directly. Another strong candidate is what we call an axion. Axions are extremely light particles that were originally proposed to solve a completely different problem in physics. What makes axions exciting is that they could exist in huge numbers, forming a kind of invisible background that adds up to a lot of mass. Unlike WIMPs, axions are becoming increasingly favored because they fit well into theory and are actively being searched for with highly detective sensors. Another third possibility is sterile neutrinos. These would be the heavier relative to neutrinos we already know about, but ones that don't interact through the normal forces except gravity. If they exist, they could help explain certain small-scale structures that we see in galaxies. The important thing is this: all of these candidates are testable. Scientists are not just speculating, they're actually building experiments to find these particles or rule them out. There's also another idea. What if dark matter isn't matter at all? Some physicists have asked whether our understanding of gravity itself may be incomplete. An alternative theory is called MOND, or Modified Newtonian Dynamics. MOND can explain why stars in some galaxies rotate the way they do without requiring dark matter. However, when we look at larger systems like galaxy clusters, cosmic microwave background, or events like the Bullet Cluster, MOND struggles. To explain all observations consistently, these modified gravity theories often end up needing some form of unseen mass anyway. Because of this, the current scientific consensus is that model gravity alone cannot explain everything we observe, while dark matter can. So where does that leave us? Dark matter is not a placeholder for ignorance. It's a name we give to a real, measurable gravitational effect that shapes galaxies and the large-scale structure of the universe. What we don't know yet is what dark matter is really made of. And that's what makes it one of the most exciting problems in physics. We have overwhelming evidence that something is there, influencing the universe on the largest scales, and we are closer than ever to uncovering its true identity. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye.